life, first time I have completed the chapter stoichiometry, right? Most of you are very sincerely involving in the classroom. Thanks to all those students who are really interested subject, right? Subject is important here, not other things. So that stoichiometry is over. But if you suppose, for example, you leave the chapter as it is, then it is very volatile. You may skip that one. So always being in lockdown, you can take advantage of time and you can say daily just half an hour, even not 40 minutes, only 30 minutes spend with the stoichiometry problems, the stoichiometry concept,
How?
especially you people are weak in calculation of oxidation state. You are very much weak in finding out n factor. Go on doing practice from different books. I have given you different sources: physical chemistry by O.P. Tandon, physical chemistry by P. Bahadur, physical chemistry by Prabhat Kumar. Any one book you can take, right? When you are attending inorganic chemistry classes or organic chemistry classes, every lecturer says NCRT, NCRT, NCRT. They are 200% correct. But when you come to my class, I say no, physical chemistry, NCRT is not sufficient for us. We have to go for a wide range of discussion. Therefore, yes, NCRT will give you borderline of the syllabus, what to do, what not to do. But what is depth of the syllabus? You have to go on enjoying any one book. Don't take 3, 4 books. Keep one book as a reference book. Avasthi is useful only for numerical problems. Avasthi is useful not only for stoichiometry beta, it is useful for a whole physical chemistry. So Avasthi is excellent for stoichiometry calculations. Level 1, do simply level 1. Enough for you at this stage. When you come to second year, when we are having revision, then we can go ahead. If you are having college material, go ahead, no problem, excellent. You can also solve those problems, right? And try to solve one by one, whether you are following in Avasthi, whether you are following college material, no problem. Every material has good content. Only the problem is it will have a 10 problem, that will have 12 problems, that much only, right? But whatever you are doing, do in sequence. आज जोश में आ गए 10 प्रॉब्लम कर ली कल खामोश बैठ गए, ऐसा नहीं करना है. यू हैव टू गो इन ए वेरी सिस्टमैटिक वे. डे 1 सर 5 questions enough, I don't want to do more than 5. Go ahead, very good. Next day 5 questions, next day 5 questions. Go on doing one by one in sequence. Wherever you have doubt, you can clarify with me. All right, now come to the next chapter, second chapter. This is named as structure of an atom. Structure of an atom. How to proceed for this? What is the nomenclature here? What is why we are saying structure of an atom? Since 8th class onwards, you people are studying atomic structure, atomic structure. But this question, the question why we are calling the word structure of an atom, what is the reason behind it? I don't think that it came across to you in your classrooms or in your mind. Suppose, for example, you were talking about the background of the stoichiometry initial classes. You said, sir, atom is divisible. Very good. And then after you said, no, sir, atom is divisible to get hundreds of particles. And then you said, no, sir, all they are not necessary for us. If you want to understand physical and chemical properties of matter, only electrons, protons, and neutrons are sufficient for us. And I'll further say simplified way, I don't want neutron also. If you want to study what is chemistry, study physical and chemical properties of matter. So whenever you are restricting yourself in terms of chemical properties, I don't require neutron also, I require only electron and proton. So we'll say that if you want to study chemistry of matter, that is the study of physical and chemical properties of matter, we require only three fellows. One is electron, proton, and neutron. Now our discussion here, once you know all this background, then you say, sir, where is the electron available? You are saying atom consists of electron, proton, neutron. Very good, sir. But where are they available? How they are available? What is the way of arrangement? The question comes, how they are arranged. Suppose, for example, your father wants to construct a beautiful house, as we say dream house. He want to construct, then what they will do, what you people will do, one night's day you'll just have a coffee and sit all of together, mommy, daddy, brothers and sisters, and discuss how many bedrooms are required, how many study rooms are required.
चल रही क्या क्लास रेहान आवाज कर रहा क्या जी आवाज कर रहा क्या हाँ कर रहे ना
And where should be the location of drawing room, where should be all this we people first discuss, and then you will see all this to your daddy. Your father will go to a person called architecture, and he will describe, sir, I am in need of all these things, this is my plot dimension, I want this one. What architecture will say, come on sir, meet me after a week. He will prepare a model. What is the meaning of model? Model means arrangement of your desire. You said, I want a drawing room, I want a study room of this dimension, I want bedroom of this dimension, I want so many washrooms and all. He is able to arrange your desire in a given space. Our space is an atom. Our space is an atom. And in the atom, our desire is to locate where is the electron, where are the protons, where are the neutrons. For that purpose, we have to go to the architecture. And who are those fellows? Scientists are the architectures, and they will give you structure. As the architecture is giving you, once after 1 week, when your father will went to that person, he will give 4 5 models and say, sir, go home and sit your family with your family members and decide which you like, then I'll finalize. Exactly in a similar way, the scientists have given us structural arrangement of, okay, where is the electron available, how they are available, where is the proton available, how they are available, what is the arrangement, what is the number, what is their location. This is known as structural representation of contents of an atom. Structural representation of contents of an atom. And based upon that, yes sir, okay, because of this we have this property, because of this we have this property, consequences. So what is the structure of an atom? What is atomic structure? Here the job of our job as a student is to understand location, arrangement, and position of electron, proton, and neutron. We don't discuss here in this case. If you want to understand that, we should talk about models. Yes, structure of an atom is discussed in terms of different architectural models. And the models were given by different scientists. One of the person was J.J. Thomson. So we are not going to discuss that one here. And next one is Rutherford. It is also not necessary for me, but I'll go back so that I can have some information for my future discussion. So I am starting with Rutherford atomic model. Atom is the smallest part of matter which is divisible, resulting in a large number of subatomic particles such as electron, proton, and neutron. Very good. All subatomic particles will be in the nucleus. In the nucleus. This is the conclusions. Actually, I am disclosing first to you. And only electron is revolving around the nucleus in extranuclear part of an atom. Okay, okay, sir. Now I am getting an idea that atom consists of two portions. One is called a nucleus and one is called extranuclear part. Okay, like this. We are having nucleus, and this is known as all extranuclear part in which electron is dancing throughout the space, and this is called extranuclear portion of an atom. Extranuclear portion and nucleus put together, if you combine, it is called an atom. Right now, atomic structure of an atom deals with study of number of electrons, how many, and where they are, arrangement and location through different models. Right, the first model has been given by J.J. Thomson, but it is discarded. We are going to Rutherford's atomic model. This model is also known as alpha rays scattering experiment. Listen carefully, because what you have learned up to 10th class is a different story. Here what we are discussing is something totally typical and different, right? Reality is faced in our classes. Rutherford has first of all a plan. What his plan? I want to know where are the electrons, where is the proton. That's my job. See, let us try to go to visualize as if you are Rutherford, right? You are now working as Rutherford and thinking, I want to know the model. What? How to know model? What is the meaning of model? Where is the electron? Where is the proton? How to know where is the electron, where is the proton? Come on, let us do one thing. Take some particle and hit with that model, atom, some atom I'll take and hit it. If you are hitting, then what happens? Suppose, for example, you are hitting with a positively charged particle. If electron is there, it will have no problem, it will go. If there is empty space, it will go. But suppose, for example, if you are having positive particle, that particle may come out. That particle which you are having positively charged particle, it may come out. And similarly, if you are having electron, suppose you have taken negative charge particle, right? And you are hitting with that negative charge particle to matter. What happens? Wherever we are having electron, it will be repelled out. Wherever you are having proton, it will be attracted. He has selected positively charged particle, right? Alpha rays. Why alpha rays? Come on, first of all, what are alpha rays? Alpha rays are radioactive rays, right? In your lower classes, teacher told you alpha rays, beta rays, and gamma rays are called radioactive rays. Today you have to learn a new information that alpha rays, beta rays, and gamma rays are radioactive rays, and gamma rays are identical to electromagnetic radiations. Electromagnetic radiations, gamma rays, come in both the categories. Radioactive rays, yes, and electromagnetic radiations also, yes. Whereas alpha and beta are not electromagnetic radiations, they are radioactive rays. Today we have disclosed 4 marks question. Alpha rays are not electromagnetic radiations, they are radioactive rays. They carry plus 4 units charge, sorry, plus 2 units charge and 4 units mass. They are having charge, they are having mass. And if suppose they are allowed to propagate, move, they are made to bombard, they will have very high kinetic energy because mass is more, half mv square. So what Rutherford was interested, that let us try to bombard alpha particles on atom, right? And he wants to know how many alpha particles are coming out, how many alpha particles are deflected back, because if they are getting deflected back, means there must be positive charge, from there they are getting deflected. And if they are going through this matter, it means there is either empty space or you should have electrons. That was the idea, that was the idea developed. Acha, how to know electrons are coming out? Because electrons are coming out because therefore we should honor that yes, he has taken gold, thin foil. This atomic model is based upon alpha rays scattering experiment, in which alpha rays emitted from a radioactive source are allowed to pass through a thin foil of gold matter, right? Gold at that time, now we can take matter, and then made to fall on zinc sulfide screen, because you can count the number of scintillations, you can count the position of scintillation. Alpha rays, who are these fellows? Alpha rays are radioactive rays carrying 2 units positive charge and 4 units mass. People call this as identical to helium nucleus. Why? Helium atom atomic number 2, mass number 4. We are having 2 protons and 2 electrons, right? So if suppose, for example, we are removing 2 protons, 2 neutrons and 2 electrons. Remove 2 electrons. What is left out? 2 protons, positive charge, 2 neutrons, no charge, plus 2, and mass 2 plus 2, because mass of proton and neutron are almost same. Therefore, we are having helium nucleus. So some people say doubly ionized means plus 2 charge. Ionized means remove electron. Where there are 2 electrons, remove 1 electron, singly ionized. Remove 1 more electron, doubly ionized, right? So helium nucleus are doubly. So wherever you have alpha particle, you can say helium 2 plus, right? When alpha ray falls on zinc sulfide screen, a bright spot is formed known as scintillation. Scintillation is bright spot. Aim of the Rutherford and his student was how many scintillation, location of scintillation. Rutherford planned to count the number of scintillations falling on lead sulfide, zinc sulfide screen and their location also. Then, for that purpose, he has taken this type of arrangement. He has taken radioactive source and he has taken a very, very circular type of disc. Right, this figure is have one thing missing here. There is one more plate here behind this one. Behind this source also he has kept one zinc sulfide screen plate. Right, now he observed, see the observations. He observed that a very large number of alpha rays are coming here on the whole side. Most of the alpha particles are penetrating without any deviation. What is the meaning of that? This means to say that we are having no disturbance. When you are saying no disturbance, no, no, sir, I am having two conclusions. One conclusion is when a large number of alpha particles are going without any deviation, it means it must have a large empty space. Rule number one says this conclusion. Rule number two says, no, sir, I am thinking that since large number of positively charged particles are moving without any deviation, there will be something who is welcoming that fellow known as negatively charged particle. Yes, rule number two is also correct. He is thinking that, sir, we are having very large space consisting of electrons. Yes, both of these conclusions are supposed to be correct. Hence, whenever we are having this type of discussion, then normally what we can say, yes, but it is the first slide. It is the first slide only. Once we are having this one, then if suppose, for example, you are observing deviation, see here, as I'm going closer, there is deviation with some angle of deviation, more angle of deviation, very large number of angle of deviation. This means to say, as I am going towards the center, as I'm going towards the center, we have more and more deviation, more and more deviation. Therefore, we can say, yes, sir, we are having alpha rays penetrating a large number. It is also observed that those alpha rays which are exactly going to the center are getting deflected back. What is the meaning of that? Okay, sir, someone is standing at the center who is saying, go back alpha rays. Who should be that fellow? That fellow should have similar charge because your teacher told you like charges repel each other. Therefore, Rutherford concluded that at the center, there must be something which carries positive charge. And around this center, there will be large space which is either empty or carrying negatively charged particle which are named as electrons. That was his conclusion based on this experiment. Therefore, we can say experimental observations and their conclusions may be given as number one. A large number of alpha rays are penetrating through matter without any deviation, indicating that a very large portion of an atom is empty or it may carry negatively charged particles. Some of the alpha rays gets deviated through certain angles. Angle of deviation increases towards center. As I'm going towards center, angle of deviation is increasing, right? I can explain you by one more figure. Just wait for a while. And 1 out of 10 power 5, take care of this number, 1 out of 10 power 5 rays gets deflected back. When 1 lakh radiations are going without a deviation, 1 ray is coming back means the positively charged center is very, 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 very small. 1 out of 10 power 5 rays gets deflected back, indicating that the central portion of an atom carries positive charge. That is the main contribution towards science by Mr. Rutherford, and till now, no one is saying it's wrong. It is accepted. This is the way. See, large number of alpha rays are having straightforward, no deviation, indicating that either this space may be empty or this space may carry electrons, negatively charged particles. And see this, as I'm going closer, first, second, third, fourth ray. Take fourth ray. If I'm taking fourth ray, there is some deviation. Take fifth one, more deviation. Sixth one, very large deviation. Similarly, in the case, as I'm approaching towards the center, the rays are getting deflected back, means someone is there who is saying, please don't come to me, I am also having identical charge as that of you. And see this one, double headed arrow, it's going and coming back, deflected back. And this, when you have 10 power 5 alpha rays are going out, only one ray is coming back, indicating that there is a very small portion at the center. Number one, very small. Number two, at the center, which should carry positive charge. Then Rutherford says, yes, protons are available at this in this nucleus. At that time, neutrons were not being discovered. Therefore, he has not discussed anything. Neutron have been discovered by Chadwick very large later on time. Now, this model, based upon all these experimental evidences and conclusion, can be given as atom is an empty hollow sphere. First point. Number two, nucleus is centrally located. Take care of each word here in this case. Centrally located, point number one. Positively charged, point number two. Smallest, point number three. Densest part of an atom, right? These are the 4 points he has given, and they are the valuable information about the nucleus given at that time. Till today, no one has changed even a small amount of sentence. Centrally located because a large number of particles are deviating. 1 out of 10 power 5 is coming back from the center, exactly from the center. Positively charged because we have deflection. Smallest because 1 out of 10 power 5 rays. 10 power 5 rays are going, but only one is coming back. Therefore, it is smallest. Densest. Why densest? Remember that mass of electron is negligible as compared to mass of proton. Total, therefore, some people say total mass of an atom is concentrated in the nucleus. Total mass of an atom is concentrated in the nucleus, right? And then he said electrons revolve around the nucleus, identical to that of planetary motion, planets revolving around the sun. Therefore, people call this as a planetary atomic model. This was the mistake. This was the point where he slipped, right? He has given very careful sentences. Somewhere here he has gone wrong, not by specifying how they are revolving. Simply he said, as if we are having motion of the planets, right? That was his model. Write down this, then we'll proceed for the next discussion. Take down that, turn the page, go to a fresh page, and write down atomic structure, second chapter, right? And systematically write down everything and draw the figures properly. Don't try to take a screenshot. You should be judge yourself, be honest, and write down systematically everything. Go ahead. Once it is finished, tell me, I'll go ahead for the next slide. I think you are not understanding properly. You're not understanding properly. But listen carefully, Imaduddin. I said one alpha particle is coming out of 10 power 5. How do you know that alpha particle is coming back? That alpha particle creates scintillation on the screen, which is kept behind the source. Yes. Naturally, source can emit only in one direction. They're allowed to go in only one direction. That is a lead, that cubical box which I have shown to you. It is a lead content. So alpha rays are going only in one direction. But when you keep a slide behind it, there also you are getting something. Where from it is coming? It's not coming from the source. It is coming from the deflected part. 1 out of 10 power 5. That you can check out scintillations on the screen kept behind the source. Got it? Fine. No, but I am sorry, Jasim. We are not going to discuss anything about stoichiometry. You people have given me very, very much pain. Thank you for that. I'm not going to discuss anything in stoichiometry. It's over, but it's completely over. Stoichiometry is over. No discussion. I don't know stoichiometry. I don't know stoichiometry. Thank you for your support and pain which you have given by leaking the passcode to your generous and honorable students. Thank you. The discussion, please don't further pain me. I don't want to discuss about stoichiometry. Into this also, I'll wait for 1 or 2 days. If you are cooperative, I'll go ahead. Otherwise, I'll say simply, I am not able to teach your learned students. I am not a suitable teacher. Please arrange somebody else. I'll quit the job. I am not made for those type of students, but I am some different thing. I know better. I know most of you are very sincere. I know. I can understand the way with you have done problems of stoichiometry. I know it. Not all. Only 1 or 2 are there. Those are there in your class sitting now and they are leaking the passcodes and supporting the members. No problem. No problem. Go ahead. I'm a teacher, beta. I'm a teacher. आसमान की तरफ मुंह उठा के थूकने से कुछ नहीं होता आसमान को. आसमान आसमान ही रहता है. Yes, shall I proceed? Please go ahead. Please draw the figures properly. Draw the figures properly. Go ahead, go ahead, no problem. Go ahead. This is first slide, beta. This is first slide. Ahmed Hussain. This is the first slide. Okay, wait a minute. I should see this one. Slide number 1. This is first only. Shall I proceed? Is it over? Okay, okay. Go ahead, go ahead, go ahead, go ahead. No problem. Write down, write down, write down, write down. We are not in a hurry. Write down. Are not. Where is no, 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 this that is not. I have not discussed, but आएगा आगे आएगा आगे. It will come in the next discussion. Not I have not explained that one. वो मेरे पास figure ऐसा मिला तो I have drawn that one. Are not. I have not discussed about are not. It will come next slide. It will come. Shall I proceed? Nasser, is it over? Abdul Rahman, is it over? Bilal. Oh, go ahead, go ahead, go ahead. No problem. No problem.
मैंने ड्राइंग कर लिया
अभी Faraz, is it over? Done. Now, once you understand that, okay, sir, I got idea of Rutherford's atomic model, then we had to go ahead. What is the meaning of going ahead? Going ahead means what are the plus points of this aspect and what are the difficulties, drawbacks, right? Once you understand the drawback, then you can say, yes, sir, now I can improve based upon the drawbacks. So, first of all, once he has given all the statements, people started asking questions, Mr. Rutherford, can you explain stability of an atom by your model? Listen carefully, because it is connected to the whole discussion. One by one, there is a chain. Thus they ask you, can you explain the stability of an atom? He said, no problem, very simple. He ordered all the available scientists in front of him and he said, consider, I am giving in my language to understand the students, consider a thread you have taken in your hand and one end. And suppose, for example, your goes on rilling that one end of the thread you have tied a stone, the other end is in your own hand, and now you are reeling it one. Once you are reeling it, what you are observing that as long as your force is constant and very large, then the stone is moving with a constant distance known as length of the thread becomes equal to radius, right, of the circular motion. As long as your hand is maintaining that force, yes, the stone is goes on moving in the same circular paths. Once you just lose your hand, F is equal to 0, then what happens? The stone will go away tangentially. The stone will go away tangentially. When you are having this type of motion, what is going on actually? Go to the physics discussion. Whenever you are having circular motion, people say that there is a force acting towards the center, which you people call centripetal force. And people say, according to third law of Newton, for every action, there must be an equal and opposite reaction. Therefore, as we are having centripetal force, there must be an opposite reaction known as centrifugal reaction, right? You may enjoy this in physics. So there are two types of forces which are balancing. Rutherford said, whenever electron is revolving around the nucleus, there will be one force acting towards center known as centripetal force. What is that? Electrostatic force of attraction by the nucleus, by the proton over the electrons in the last shell. And then we have one force which is acting outward known as centrifugal force. Because of these two forces, atom electron is revolving in the same path. He explained something like this. People say very good and they clap. Rutherford's model has been accepted, and it is goes on accepted by so many years. During that time, one team of people they are working with physics concept of charge particles. While they were doing experiment, they observed one phenomena that is called concept of electrodynamics. What they suggested that if a charge particle, listen carefully, if a charge particle is revolving around another oppositely charged particle, I'm repeating, if a charge particle is revolving around another oppositely charged particle, revolving particle will have loss of energy. Revolving particle will have loss of energy. And what happens if you have loss of energy? The particle which is losing energy will be attracted, and further. Now imagine the situation in case of Rutherford's model. Electron is revolving around the nucleus, oppositely charged particle. When electron is revolving, according to concept of electrodynamics, according to Rutherford's theory, centrifugal force, they are balanced each other, therefore no discussion except circular motion. But what these people say, yes, concept of centripetal force and centrifugal force are applicable, but they are applicable in case of charged to uncharged particles. You said thread, acceptable. You said stone, you said hand. All these are uncharged particles. But when you are applying the concept in case of charged particles, we should have to apply one more idea behind along with that one. They are not wrong. They are applicable. Concept of centrifugal force is applicable. But at the same time, you have to say that if a charged particle such as electron is revolving around another particle, oppositely charged particle such as proton, the revolving particle electron should have loss of energy. If it is losing energy, it will not follow left the circular path. See the left column, right? See the pointer. It is not follow this type of path, but slowly it will come closer and closer and closer and closer and closer. Ultimately, it may collapse into the nucleus following a spiral path. Therefore, according to concept of electrodynamics, Rutherford has a first drawback. It is not suitable to explain stability of an atom, right? He explained it very nicely, but he has applied concept of centrifugal and centrifugal force, which are necessarily applicable, but not only they are applicable, we should apply some other concept in case of charged particles. He missed that idea of charged particles concept, right? This is first drawback. Second drawback is, suppose for example, if electron is not following this path, if electron is losing energy, continuously it is losing energy, loss, and a collapsed nucleus, the loss of energy will be a continuous process. Suppose if you take the released energy in a continuous manner on a photographic plate, we get a spectrum known as continuous spectrum. Take a break here. Sir, what is the meaning of spectrum? Doubt. Okay, spectrum. This boy has very good knowledge, very high spectrum of knowledge. So many things he know. So many things he know. Exactly in that way, when we talk about the word spectrum, it is arrangement of color, supermarket discussion, arrangement of colors. Scientists, no, sir, it is arrangement of energy, it is arrangement of frequency, it is arrangement of wavelength. In increasing or decreasing order is called spectrum. For example, go back to your lower classes where you have said, sir, we are having violet color, we are having indigo color, we are having blue color, we are having green color, yellow color, orange color, red color. We have said all these colors are arranged. Now, point number one, they may be arranged in a continuous manner, continuous spectrum. They are arranged in a discontinuous manner, line spectrum. Sir, what is the meaning of continuous spectrum? Come on, have a look on the sky whenever you observe rainbow. Sir, we are having so many beautiful colors created by the God. But the problem is we are unable to know where the first color is ending and where the second color is starting. Continuous spectrum. It is a continuity. Whereas, suppose for example, you have taken a paper and color pens and you are drawing. First, you have drawn violet color. Then you have left a small space, indigo color, space, again blue color, again green color. If you are drawing like this, it is called as line spectrum, right? So according to Rutherford's model, if you accept it that electron is following spiral path, it is losing energy continuously. Whenever we have loss of energy continuously, there should be continuous spectrum according to Rutherford's model. Come on, go to the lab. Take an atom and study atomic spectra. When you study atomic spectra, it is observed that you are having different lines available. Okay, it means experiment says that atoms always gives you line spectrum. Atoms always gives you line spectrum. But Rutherford's theoretical discussion says no, it is supposed to be emission continuous spectrum. Hence, we say that experiment is always correct. Therefore, Rutherford's second drawback is it is also not able to explain existence of line spectrum. If you want to summarize what we can say, Rutherford's model plus point is existence and location of nucleus. Sign drawback is number one, fails to explain stability of an atom, also fails to explain existence of line spectrum. Come on. Merits of Rutherford's atomic model. It is the first and most accurate model for identification of nucleus and its location. Limitations. Number one, it fails to explain stability of an atom as revolving electron follows a spiral path. How it is spiral path? Like this, see, continuously it is coming closer. There is no break somewhere here. Continuously it is coming closer and closer and closer, and therefore it may collapse. Therefore, it is unable to explain existence of an atom as a stable system. And it also fails to explain existence of line spectrum. If suppose it is continuously losing energy, the spectrum must be a continuous spectrum, but experiment says atom should always gives you line spectrum. Right? Now, that is the end of Bohr's atomic model. That is enough for us to understand. Now, with these defects, we will proceed. Yes, sir, let us try to understand some other aspect. Now, I am taking a different topic here. It is a mathematical approach to Rutherford's model, suitable for only IIT mains. Chances are very less, but may be possible. There is a heading called distance of closest approach. What is the meaning of approach? Someone is coming closer. Who is coming closer? Alpha particle is coming closer to the nucleus. If you observe that experiment, closest distance. Now go back. See here. If suppose, for example, you are discussing this alpha particle, which is getting deflected back, this R0 is closest distance of approach. Practically, it will never touch the nucleus and get back. But theoretically speaking, if I say, suppose, for example, you are saying, sir, alpha particle has very high kinetic energy. One boy says like this. Rule number two says, no, sir, I have maintained nucleus with very large number of protons. Gold, 79 protons. If I take silver, 47 protons. So if you are having less number of protons, repulsive force will be less. Alpha particle may come further close, but remember, it will never penetrate into the nucleus because of repulsive force, right? It can touch and go back. This is not possible. Remember, listen carefully. It is not possible. Theoretically, I am saying that this alpha particle may go and touch and come back. If you want to enjoy this example, come on, take a ball in your head and throw it up. Here. Once you are throwing the ball up, you are throwing the ball with very, very high force and velocity is more. But as the ball is going up, its velocity decreases. And when it reaches to maximum height, kinetic energy becomes zero. Total kinetic energy will be converted into potential energy. Half mv square is equal to mgh. And the ball now comes to rest and then starts retracing the path back. Exactly in a similar way, it is vertical motion under the influence of gravity. Now here in this case, we have horizontal motion under the influence of electrostatic force of repulsion. Now imagine that when you are having alpha particle, this is R0, that is the point closest distance. Come on. Once you are saying, sir, we are talking about closest distance of approach, then consider alpha particle getting deflected back. Now see here. This is the situation practically observed that alpha particle is coming with very high kinetic energy As it is approaching toward the nucleus, kinetic energy decreases, decreases, decreases. Suppose it is the point where from it is deflecting back, then at this point kinetic energy is zero. No, sir. That kinetic energy is completely balanced by electrostatic force of repulsion. Both of them becomes equal. Therefore, the alpha particle is now retracing back. When it is retracing back, again kinetic energy increases, increases, increases because of repulsive force. Now, what I am taking here, the word closest, take care of the English, closest. Therefore, theoretically speaking, in physics, you may have problems in second year that you can calculate all this. But what I am doing here in this case is, let us imagine that alpha particle has very high kinetic energy, and here number of protons are less. Instead of using gold, 79, I'm using, say, for example, silver, 47. In that case, the alpha particle may come to this point and then reflect it. If it is so, what is the closest approach? Center to this point. Is it not radius of nucleus? Yes. This experiment is therefore useful to calculate the radius of nucleus also. That is known as closest approach. But practically, remember, it will not touch this one. It will be somewhere here because of very high electrostatic force of repulsion. If it is so, at the point when it is rebouncing, I should say, kinetic energy must be equal to electrostatic force of repulsion. At closest approach, practically this one, theoretically I am saying up to the nucleus. Let R from the center of the nucleus. This is center and this is total R from here to here. I am thinking that it may be here to here, radius of nucleus, maximum possibility. The alpha, let at the closest approach of alpha particle, kinetic energy becomes equal to electrostatic force of repulsion. Therefore, the amount of work done by the electrostatic force of repulsion must be equal to kinetic energy. Go back to again physics. There is a chapter called work over energy. There you will learn, or you have learned it. Change in kinetic energy must be equal to amount of work done. Change in kinetic energy. What is the kinetic energy? Half mv square. No, sir. What is the kinetic energy just when touches the surface? Zero. Half mv square minus zero is equal to half mv square. This is kinetic energy of alpha particle, mass of alpha particle, velocity of alpha particle is equal to electrostatic force of repulsion. Go back to your 10th class. Teacher told you, consider two charged particles Q1 and Q2 at a distance of R. She said, force of attraction or repulsion is directly proportional to Q1, Q2, product of charges, inversely proportional to square of distance between them. It is called inverse square law. Yes. If you say F proportional to Q1, Q2 by R square, remove the proportionality. You have tried something known as proportionality constant. F is equal to K into Q1, Q2 by R square. And what is that K? K is given as 1 by 4 pi epsilon naught. This whole number 1 by 4 is a number, pi is a number, epsilon naught is called a constant of medium. Name is permittivity constant. Don't take much serious involvement here in this case. If you are able to remember, go ahead. Permittivity constant epsilon naught. 1 by 4 pi epsilon naught is value of K. Now we are talking about discussion known as work done. What is work done? F into S. F into S. What is force? 1 by 4 pi epsilon naught Q1 Q2 by R square into S. What is S? R, right? Thank you, beta. Go ahead. Please concentrate on the screen. So half mv square is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square and R gets cancelled. Half mv square is equal to 1 by 4 pi epsilon naught Q alpha Q1. What is Q1? Charge on the alpha particle. What is the charge on alpha particle? 2 times charge of proton E. I am not writing E minus. Charge of proton 2E. And what about this fellow gold? 79E. No, sir, I want to enjoy general discussion. Then ZE. What is that? ZE is supposed to be number of protons into E. Hence, half mv square is equal to 1 by 4 pi epsilon naught into 2z square by R. Yes, this R is known as closest distance of approach. Okay, R is equal to 1 by 4 pi epsilon naught. If you simplify, 2z square by half mv square is given as K, E, K alpha. If problem is given alpha particle kinetic energy, go ahead. If problem is given with the velocity, go ahead by this expression, right? Simply you have to remember half mv square. All this is not to be memorized. We are not parrots. We are scientists. Half mv square is equal to electrostatic force of attraction or repulsion into work done, right? Into S. So it will be simplified. We'll do problems based on that one. This 1 by 4 pi epsilon naught is a constant. Value of that is given as 9 10 power 9 Newton meter square per coulomb square. And what is R? R is called closest distance of approach. That is the end of Rutherford's discussion as a whole. We are having some numerical problems based on that we'll discuss in the next class. Please carry on all of this as it is. Go ahead. What is E? Abrar, abrar. थोड़ा जरा जहन पे जोर डालो बेटा. सोचो क्या होगा. ई किसकी जगह पे रखा मैं. you know it abrar, you know it. थोड़ा सा दिमाग पे थोड़ा सा प्रेशर डालो. Q is charge. Charge an alpha particle. Each alpha particle carries 2 times positive charge. What is a positive charge? E. Charge of electron. Charge of proton. Both are same. 2e. Charge of alpha particle. Ze. Charge on gold particle. In case of gold, Z is 79. If you are taking some other thing, Z has to be changed. Let the students are writing the second slide. Let them complete this. Then we'll go. First, let us complete this slide. Then we'll go. If you have requirement of anything from first slide, they are writing. Students are writing. Let them complete. Once it's over, we'll go back. I'm a teacher, but I am a teacher. I have to forget all those things. Is it over? Hmm. Sufyan. Nihal, is it over? Fine. Go ahead, go ahead, go ahead. Fine. That will stop here. We have problems based on this one that we'll discuss in the next class. Thank you. Assalamu alaikum. Okay, okay, okay. There is a problem of slide one. Someone is asking slide number 1. Who is that boy? No, no, not do not memorize. Do not memorize. Just refer physical chemistry by O.P. Tandon. O.P. Tandon. Ryan, first slide you were asking. What is that? Please take up. I'll go to some other classes there. Do not memorize the formula. Just memorize one thing. What is that? Kinetic energy is equal to electrostatic work done. Kinetic energy is equal to work done. And for books, NCRT, okay. Once you can read that NCRT, but better is physical chemistry by O.P. Tandon for theoretical concept, or Prabhat Kumar, right? Problems, anyhow, we are doing in the classroom, and Avasti, if you do, very good, excellent. Ryan, is it over? First slide. Done. Assalamu alaikum.